Thank you, Jim. I'm flabbergasted, actually. Yes, I'm sure there are questions, probably about mineralogy and temperature, pressure. Any questions?
I'm interested in the hydrogen because hydrogen will diffuse wherever it possibly can. So how is it that you can go prospecting for hydrogen without it all escaping?
It does all escape. It's escaping now. It's escaped for the last 90 million years, but it's part of the serpentinization process. I'm no expert on hydrogen, and I'm certainly not a geochemical expert on serpentinization, but that serpentinization reaction is the one that produces H2, which comes off. So all those springs are coming out either hydrogen, nitrogen, or methane. And I don't know enough about it, but I do know that there's 3 companies that have got huge interest in Fujairah, Ras Al Khaimah, and Oman, who are prospecting for it. And as I said, the biggest problem with hydrogen, well, one of the many problems, is that you don't have a reservoir. You need a big fold or something to trap it. You don't have that in hydrogen. So how they're going to do this, I have no idea. I'm very skeptical.
Thank you. Last year, I tried to get to the top of Jebel Sham, but it's a military area and I didn't get further than I could go, obviously. But from what you've shown me tonight, it's picked up on the points that I couldn't see from there.
Right.
So it's been quite interesting to see all that. Presumably you were able to get up there without a problem.
Yeah, we did 4 new climbing routes up the north face, the steep one.
Oh, right.
And the other face, you can drive up towards the Grand Canyon now.
That's where I was.
Big tourist place.
Yeah, to the Grand Canyon.
What you can't do now is go up to the very summit because there's a radar station on top.
Exactly. Yeah.
But if you walk around the rim of the Grand Canyon, you can get right up to 3,000 meters and along the ridge all the way. Okay. It's fantastic trekking up there. Okay. And you can there's trekking routes that go right from the bottom. That picture I showed with the stratigraphy, from those villages, there's routes that go 2,500 meters.
Yeah, you
up through ledges.
You can see the paths up, but
yeah.
As I said, I couldn't get any further because it's a military area. But it's interesting to see what I missed.
Yeah, yeah.
Your closest, and I'll come to you.
The actual intense folding that you showed, and sometimes in carbonates, sometimes in the radiolarian cherts.
Yeah.
It's quite difficult for us sometimes to imagine that these are really, really hard, competent rocks, yet they're being folded. So yeah. This is the folding must be happening, plastic deformation. Deformation.
Yeah.
So does that give you another sort of measure of the depth? Because it has to be happening at a point where sure. The rocks are behaving like plasticine.
No, absolutely. They're all below the brittle ductile transition. So the rocks I showed in the Permian carbonates that were folded like crazy, those are in carphalite grade. That all the very pilitic units in them have carphalite. So those are happening at 20 to 25 kilometers depth. The radiolarian cherts are different because that's a shallow fold thrust belt. So the multicolored striped rocks, that outcrop, that is formed purely by brittle faulting and thrusting associated with the emplacement. And then the stuff in the eclogites, the eclogites, which are again isoclinally folded, that's happening at 100 kilometers depth.
So, sorry, I've got to try and get my head around that. What you're saying is for the radiolarian cherts,
yeah.
which are doing this,
yeah,
that's the folding is the result of brittle deformation.
Yes.
On a micro scale.
Yeah, they have not been buried deep.
Yeah.
So you can see structures like that in the Moyne Thrust Zone if you go up there. So they are related to extreme imbrication thrusting.
Yeah.
But those have traveled a hell of a long way. You know, those radiolarian cherts have probably been thrust about 100 kilometers minimum over the continental margin. So they're not going to preserve, nice flat bedding anymore.
Amazing. Right. Yes, Roger.
Yes, thank you very much. It was fascinating. I feel I should enter a Scrabble competition immediately. The number of technical terms there. But some weeks ago, we had an evening where we were bringing along our own samples, and I brought along a rock that I'd collected 50 years ago from the Grenville Front in northern New York State, and it was a garnet pyroxene amphibole taken from a garnet mine where the garnets could get up to 1 meter across. And I wondered, you alluded to the lizard and other similar environments. To what extent can you create a standardized, if you like, mineralogic, igneous, metamorphic model that will replicate in other geographic locations and going further back in time?
That's a very good question. Certainly with metamorphic sols in Oman, so the garnet clinopyroxene amphibole plage rocks, those are common in hundreds of ophiolites around the world. You know, you don't see them in Troodos because Troodos is just a dome. You do see them in the Bay of Islands, you see them in Palawan, you see them in a bunch of ophiolites in the Franciscan. So the ophiolite and the metamorphic sol, you can create a standard model in which most ophiolites will fit. What you cannot do is for the Himalayan type rocks, which are your rock from New York State. That's probably part of the Grenville, which is a regional metamorphic rock. And the whole Himalayas are made of that. And that encompasses pretty much everything on a PT diagram, spread over the whole thing. So in the Himalayas, you can map out the mineral isograds using metamorphic petrology. It's difficult, but when you trek up the Himalayan wadis, you look at the first formation of staurolite and the first formation of kyanite and the first formation of sillimanite. And by matching different maps, you can join them up. That's how we make isograd maps of the Himalayas. But those are metamorphic isograds, which are very well known. You know, the Barrovian isograds you see in the Grampians and the Scandian in Scotland, they're everywhere. So New York, I'm sure, is the same. You've got the same Barrovian metamorphic minerals. But the protolith could be anything. Could be shales, could be carbonates, could be peelites. So the Himalayas is way more complicated. Oman is actually quite simple. You know, well, apart from the folding.
Okay, thank you.
Anybody? Yes.
What's the climate like in Oman? And did you pick up much of their local language?
I can speak some Arabic. It's not very good, but I can enough to get by. Because when I was doing my PhD, I was on my own, just camping out in the mountains for 2 or 3 months, driving an old Land Rover, which occasionally had a puncture, and I had to walk to the next Bedou camp. But the climate is in winter, it's absolutely perfect. So if you want to go to Oman between November and March, it's perfect. It's 30 degrees, warm and sunny every day. The occasional rain and wadi flood comes down. In May, June, July, it's baking hot, 50 degrees. A rock is so hot you can't touch it. So I thoroughly recommend a winter trip to Oman, not a summer trip.
47 degrees there.
Yeah. They have had some spectacular wadi floods in the last month in Oman. You know, the climate's definitely changing up there, and they're getting much more big storms coming in. They have cyclones coming in off the Indian Ocean. Cyclone Gonu was absolutely devastating, one that swept up through the Indian Ocean about 10 years ago.
Thank you, Mike. I was fortunate enough to find myself going to Oman to work over about a 20-year period from probably about the time you were starting your research there. I'm afraid I never got to grips at that level with the geology. No chance. Because I was working in construction, not in
Right.
pure geology, but I always found the Omanis, with a single exception, to be really pleasant individuals and genuine.
Absolutely.
And I was really impressed compared with if you went to, well, not so much Dubai, but certainly Qatar and Saudi and places like that, much more difficult to work with. But the Omanis I found always very genuine and really, really pleasant
No,
individuals.
you're absolutely correct.
And the country thrived because of that attitude. And I hope
No,
they still like that with the new Sultan.
No, when you go out to the Bedouin in the mountains, you know, they are incredibly hospitable. They will drag you into the house, have a cup of coffee and tea. And it's one of the reasons why Oman is now, you know, they're acting as intermediaries. They talk to Iran, they talk to the US, they talk to anyone. And they're not aggressive. They're very, very polite. Yeah, there's a wonderful, you know, it's Arabian Bedouin culture at its very best.
Right. Very good. Let's we'll draw it to a close there. I think if you take one thing away from this, and I apologize, there's so much in there, apart from the awe-inspiring work that's gone into this and everything else. But the thing that struck me really forcibly is the whole business about why have you got an amphibolite at all? Why has a piece of the lower crust and mantle ended up on top of the crust? And that's not a simple thing to do. The physics of that are difficult. And when we were doing the lizard and we were looking at back arc spreading, and that's the stuff that you're getting put on top, and that's why you've got this sort of thing. And you've always got to have a little trick to try and get your amphibolite up on top to do this. So if you take one thing away, then I think that's a great piece of insight. Anyway, thank you very much indeed, Mike. That was terrific.
Yeah.